Okay, so the purpose of a cooling tower is to cool water, okay? The way that the cooling tower goes about cooling is through evaporation. And I'll explain more on that in a little bit, okay? So you have cold water leaving your basin, okay? Going through your cooling water pump, and then it's going to go to all the different cooling water exchangers, okay? We know to cool something down, we have to remove heat, right? The purpose of the cooling water is to cool the process, okay? So we got process, whatever it may be, on our shell side. So our cooling water is going to go in, absorb the heat from the process to cool it. Well, now our water leaving the exchanger is warm or hot, right? So now it's going to go back to the cooling tower to get cooled. This is what we call a closed loop system. It's going from cooling water tower to heat exchangers, back to the cooling water tower, to heat exchangers, back to the cooling, right? So it's cold leaving the cooling tower. And by cold, I mean like 70s, 80s, okay? Cold leaving the tower, absorbs heat, warm, returning to the tower. Let's go through the components and see how they work. When entering, it's going to enter the distribution header. We know what a header is. Something that distributes something to multiple places, right? And then it's going to go to our distribution nozzles, which are these right here. Think of a sprinkler system, like for fire in a room. It's just going to spray them out, right? From there, it's going to be going over the fuel.
Yeah.
Okay. So this is fuel. What the fuel does is breaks it up into small droplets to increase the surface area. Okay. So for example, if I have a stream of it, like coming out your bathtub or something, I have all the water in here, right? In the stream, the outside, the surface area, that's the only part that would be coming in contact with our air. Now, if we broke it up into small itty bitty droplets, and remember this is a 3D droplet, so now the air can come in contact with every single surface area of the droplets. So the fuel breaks up into small droplets to increase the surface area, so that way we can have more efficient cooling. So it's going to go down the fuel, and then it's going to go into your basin. Your air intake will direct your airflow to where it's going to go like this and then up and out the top. Well, we don't want to accidentally blow or let the air catch any of our small water droplets and blow them out the top, right? So we have what we call drift eliminators on each side. So that's to minimize drift, prevent water loss from your water droplets getting blown out. Our airflow is going to come in, it's going to direct it kind of down, right? And then go up out the fan. If the fan's at the top, that's induced draft. The fan is at the bottom, that's forced. Okay, so as your cold air comes in, it's going to absorb the heat from the water, and actually above your cooling tower, it's going to be very humid. You ever driving down the road if it's like really hot outside, like really hot, like pink of August, and you see the road blurry? That's what you're going to see above your cooling tower. So the same way you have a puddle in your driveway and it dries in the middle of August when it's a really hot day, it's not boiling, it's evaporating, right? So of course we're losing water through that evaporation. And then we've learned about backflushing heat exchangers. So when we backflush, we're also losing water. So that's where we have makeup water. It's going to be treated chemically, go through all the water treatment it needs to go through, and then we have makeup water to add as needed. Your blowdown line, so it's hot and it's wet. Think of a swimming pool in the middle of August if you don't treat it.
Yeah.
Algae build up. Or like anyone ever have an outside dog? Our outside dogs, they were big Catahoulas or hound dogs, and we had a 5-gallon bucket full of water. And if you didn't clean it on the regular, it'd fill up with algae, right? Settling at the bottom. So your blowdown line, it's going to be the lowest point of your basin, which is this bottom tower, right? Your blowdown line is going to come off of a low point. And it is going to continuously be open. We're wasting some water, yes, but we're getting rid of the algae. Okay, evaporation is happening. You think our heavy minerals in our water are going to want to drop to the bottom and cause that scale. So before the scale can accumulate and harden up, it's going to be letting it come out the bottom. Algae, dirt, mud, etc., etc. Okay, we're using outside ambient air to cool, right? So do you think the efficiency, how well it cools of our cooling tower will be affected, let's say in the middle of August compared to January? Yeah. So does the weather affect how cool it gets?
Yeah.
All right. So closed loop system, what I mean from that, A to B to A to B to A to B to A to B. Leaving our cooling tower, the cooling water is going to a heat exchanger to cool the process, which we know to cool something, we got to absorb heat, right? So the cooling water leaving the heat exchanger is going to be warmer. Because it's absorbing the heat from the process. Well, now it's warm or hot, so we need to cool it again. So where's it going to go?